Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called kth missing positive number. We were given an array of positive integers sorted in strictly increasing order and an integer k. Return the kth positive integer that is missing from the array. So let's take a look at example 1. We have an array like this and k is equal to 5. So suppose we start from 1 and the missing numbers are 1, 5, 6, 8, 9, 12, 13, and so on. So the fifth missing positive integer is 9. Therefore, the output is 9. Okay, so that's pretty straightforward. But there's another possibility. Let's take a look at example 2. We have 1, 2, 3, 4. So basically, we're not missing anything from the range 1 to positive infinity. Okay, so we have a k equals to 2. So here, we're going all the way to the right. So even if we don't have that long of the array, but we're still missing some positive integers. And after adding 2 to 4, the missing positive integer will be 6. Okay, so for the brute force idea, this should be pretty easy. We just have to set an array listing all the positive integers from 1 to the maximum of this array, and we compare, we get all the missing positive integers here, and we get the kth element from the list. Okay, that should be very easy and straightforward, but we're not going to use that because though this is an easy question, it's got some tricks that can be very eye-opening. So let's explore this. So suppose we have something like this. We have 1, 2, 4, 7, 8, and 10. Okay, so that's going to be our array. Let me put it over here. Okay, so that's going to be our array, and k, let's say, equals to 5. Okay, so basically we can, like I said, we can do 1, 2, 3, 4, and we sort all the missing positive integers, but we're not going to do that right now. Basically, we can see if, let's say, we're missing something here, right? We're missing something here when it's 7, where it should be 4, right? So in this case, I'm gonna use the index over here. Okay, so this place should be 4, but we have a 7 here, so that means we have something missing to the left of 7. And how many numbers are we missing? So we should have 4, and let's subtract 4 from 7. We have 3, and let's see, 1, 2, 3, 5, 6, and we are missing 3. Okay, and let's try this one. So here it should be 5. Okay, let me write it over here. Should be, and this part will be the index. Okay, so to the left of 8, we're missing 8 minus 5 equals to 3. We're missing 3 numbers within this range from 1 to 8. Okay, let's try another one. So here we have 10, right? And here should be 6. So the total number we're missing is it 4? So yes, we're missing a 9 here. Okay, so that's kind of the trick in this problem. And if we know, we can compare this difference with the k. If we know that it is not large enough, we should go all the way right to see if there are more missing numbers. And once we got the missing numbers that equals to k, we can just return it. Okay, so this would be like array I minus, I'm going to get the index and add 1 to the index here. Okay, so that's the thing we're going to compare with the k. Okay, so now we can use our binary search. If we see that this number is less than k, so we know immediately that we need to go right to enlarge this part to make it equal to k. Okay, and if this one is larger than k, that means we've gone too far, so we have to go to the left. Okay, and finally, when we do have somewhere that we have k, but here I think the maximum we can go is 4. Okay, so how should we approach this problem? If we have something like this, we will have a binary search, and for the binary search, I can do a left here, a right here, and the middle would be here, I guess. Yeah, that's right. So as I said, the difference of this would be 1. Okay, so that's less than k. So I have to increment this L. Okay, so in next iteration, L will be here, and M will not go here. Okay, so M will be here. That's in the next iteration. So here we have a difference of 3, right? We're missing 3, 5, and 6. So still less than k, so we go all the way to the right. Okay, now our L, M, and R will converge together at 10, and now we're still having this less than k. Okay, so we still have to go right, but here L is out of bound. All right, and what should we return? So here L equals to 6 at this point, and let's calculate the missing positive here. Okay, so we're looking for the 5th missing positive integer. So it's going to be 3, 5, 6, 9, and 11. Okay, so looks like the final answer should be L plus K. I don't know, we can do some calculation next. Okay, so why is it like L plus K? Let's say if we have a full array, something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. Okay, yeah. I think that's the full array. And now the furthest we can go is the maximum of the original array, which is array right plus k. And here it's 15, right? And we have to subtract the number of missing positive integers. So that's going to be array right minus 1, as I said. Okay, so here in this equation, this I think should be 4, And that's going to be our final result of 11. Okay, so we used the maximum we can reach to subtract the maximum that we have, the maximum missing that we have, and we got the final answer. That's going to be the kth missing positive number. Okay, so let's code it out. And this time it has to be left less than or equal to right. And the middle would be, so like I said, if array m minus 1 is less than k, that means we're not missing enough. So L should be moved to the right. Else right should be moved to the left. Okay, and the final answer would be array right plus k minus array right minus right and minus 1. Okay, so or we can return left plus k, but for easier understanding I'm trying to do this, return this. Okay, yeah, so it looks like it passes all the test cases. So the complexity, since we're using binary search, this will be log n, and for space we're not using any extra space, so it should be constant space. Let's submit it. Oh yeah, we have a problem. Index out of bound for length 1. Okay, so if we have something like this, right minus 1. Let me see. Okay. Yeah, I think that's probably here. Yeah, so if we have 1, yeah, we are out of bound, right, like that. Okay, so it's easier or more secure to return L plus K. And great. Thank you so much for watching. If you liked the video, please like and subscribe to my channel. Thank you so much. I'll see you in our next video.